Good day, my amiable viewers. You are welcome back to class. As you already know, my name still remains Mr. Ezreguai. Today, we are going to have a look at some elementary aspects of chemistry. In fact, we are going to start with acid, base, and salt. But for today's class, we are going to handle only acid and bases. Now, what is an acid? An acid is a substance which dissolves in water, dissociates to produce hydrogen ions as the only positive charge ions. Example, hydrochloric acid, HCl. When it dissociates in water, it gives H plus Cl minus. You see it as the only positive charge ion, hydrogen ions. This one is called hydrochloric acid. We also have H2SO4. 2H plus SO4 2 minus. This is another dissociation. You have HNO3. Will give you H plus NO3 minus. All these ones are also are known as mineral acids. They are inorganic acid and they are usually very strong, except you dilute it. So you also, because they undergo complete dissociation. Then you also have organic acid. This is an example of organic acid. It's called ethanoic acid. Ethanoic acid. It does not undergo full dissociation. So it gives CH3, COO minus plus H plus. So you see it's not full dissociation because there is still hydrogen ions here. So this is a weak acid. These are some examples of acid based on the definition. That an acid is a substance which dissolves in water, dissociates to produce hydrogen ions as the only positive charge ion. However, there is still another definition of acid, that an acid is a substance which dissolves in water, produces hydrozonium ion or hydronium ion. Both of them mean the same thing. HCl plus H2O give you H3O plus Cl minus. This is the hydronium ion. Hydronium ion, or can be called hydrozonium ion. So these are examples of some acid. Then acid has some properties. You have acid is some acid are very corrosive to the skin, so don't play with it. Corrosive acid, people they pour acid on, how you burnt their system, like what fire can do. So those acids are very corrosive. What do you mean by corrosive? It means it can burn, damage the skin very well. So you don't play with acid. That's when they are concentrated anyway. Then acid turns damp blue litmus paper to red, for example, and it has no effect on damp red litmus paper. So you can see an example of an acid. This solution contains acid. It can be any acid. That's why the name is not written. Any acid at all, whether it's organic or inorganic, weak or strong, it produces the same result. So let's make it damp. This is a damp blue litmus paper. It usually have to be down so that the ions that can produce the color change are made available. So we drop it inside the acid. You can see it has changed the damp blue litmus paper to red. But let's see, this is red blue litmus paper. If you drop it inside acid, it remains red. It has no effect on it. So that is how we know the solution is acidic. So some solutions that produce such result, we say they are acidic. That is how that one goes. Then we also have bases. Base. A base is a substance which reacts with acid to produce salt and water only. That is the definition of a base. Base have similar properties like acid from the other direction. Just like we said, some acid are corrosive to the skin, acids such as HCl, HNO3 in their concentrated form. The same thing with base. Some bases such as KOH, NaOH in their concentrated form. Concentrated means we'll deal with that on subsequent videos. In their concentrated form, they are very corrosive. That is, they can damage the skin. You don't play with them. How do we know it's a base? You have the OH. The presence of this hydroxide group makes it a base. Just like the acid can dissociate, a base also can dissociate to produce K plus OH minus, Na plus OH minus. So all these ones are bases. But by the definition, a base is a substance which reacts with acid to produce salt and water only. You have, let's say you have use KOH plus sodium chloride. This sodium chloride is the salt we use to cook at home. Common salt is not poisonous. However, the one you normally get from chemical reaction in the laboratory is actually not edible. Yes, because it has not undergone series of purification process. It's just from the laboratory. The one you buy in the market is what is edible and has the same formula like this. So when this one reacts, it produces KCl plus NaOH. So this KCl plus KCl plus H2O. Sorry for that. So this is a base. The name of this base is potassium hydroxide. It reacts with hydrochloric acid to produce salt and water only. Then let's use the one we use at home. NaOH plus HCl. NaCl plus H2O. This is a base because it reacts with acid to produce salt, sodium chloride, and water only. Now, just like we said, acid are corrosive to the skin in concentrated form. That's in their when there is little water in it and large amount of acid. Bases also are corrosive in their concentrated form. So let's try to see the other reactions of base. Just like acid changes damp blue litmus paper to red, base also changes damp red blue litmus paper to blue. When we say damp, it means it's wet. You must add this, use it to touch water. So bases change damp red litmus paper to blue. So this one is a red litmus paper. Let's try and see. This is a base. Any of the bases. We didn't specify the name. You can see it. It has changed it to blue. Let's do another one of this kind. You see, this is another red litmus paper. We use it to touch base solution. You see it. It has changed it. The part that touched it has changed to blue. So that is how we know a base. It changed down red litmus paper to blue. But look at ordinary water. This is ordinary water. This is a blue litmus paper. If I dip it in it, it can only make it damp or wet. It didn't produce color change. Let's also use the red litmus paper. You can see it. If I use it to touch it, it does not produce any color change. It remains red. So that is how we know it. Now, there are several definitions of base based on several authorities in the field of chemistry. We have the first one we are going to talk about is Arrhenius. Like I said, there are so many authorities that gave their various definitions about acid and bases. Notable among them is Arrhenius. Arrhenius' definition of acid and base. According to Arrhenius, an acid is a substance which dissolves in water, dissociates to produce hydrogen ions, while a base is a substance which dissolves in water, dissociates to produce hydroxide ion. This one is similar to the first definition we had. For example, you have, according to Arrhenius, HCl dissolve in water to give you H plus Cl minus. You can see it, hydrogen ions. You can also have HNO3 to give you H plus NO3 minus. You see it, both of them have hydrogen ions. And remember we said hydrogen ion in this case is a hydrogen that has lost an electron, making it to be called a proton. Then in case of base, according to Arrhenius, a base is a substance which dissolves in water, dissociates also to produce hydroxide ion, NaOH, to give you Na plus OH minus. The presence of this OH makes it actually a base. For example, we also have KOH. This gives K plus OH minus. You see it. These are definitions based on Arrhenius theory of it. So we also have other authorities in the field of chemistry that also gave their various definitions. According to this time around, we are going to Bronsted and Lowry. two scientists combine together, Bronsted and other scientists, Lowry, but normally join them together to get Bronsted-Lowry definition. But actually, they are two separate scientists, but they work together. So, according to Bronsted-Lowry definition, an acid is a proton-donor, HCl, for example, plus NH3, to give you a reversible reaction, that reaction that can proceed both ways when the conditions are changed, to give you NH4 plus Cl minus. You can see it. You can also have another equation, HCl plus H2O, H3O plus Cl minus. You can see it. An acid is a proton donor. Where is this proton coming from? Just like the previous equation, HCl to give you H plus Cl minus. Chlorine has taken the single electron of hydrogen, now forming a chloride ion with SS electron. It has taken the electron of hydrogen, making this hydrogen to have no electron. It doesn't have electron, but remember, even though it loses its electron, the atomic number still remains number 1. Still remains the same. It does not affect the atomic number because it's equivalent to the number of proton. But the electron is one is used for chemical reaction. We call it the external electron. The electron in the outermost shell, the valence electron. So this one that has lost electron is what it now adds to this to give this H3O plus. So these two definitions are definitions given by Bronsted and Lowry. An acid is a proton donor. It has donated a proton to this, so making this one an acid and this one a base. This one an acid, this one a base. But some of you will be asking, how can we say water that is a neutral solution? Because now one of our videos, we used the red and blue litmus paper to touch water, did not produce any color change. How then are we now referring to it as a base? In this regard, based on Bronsted-Lowry definition, it is a base because it's capable of accepting proton. According to this theory, any substance that is able to accept proton automatically become a base. So, because you are adding hydrogen to this to form this hydrozonium ion, or hydronium ion, both names are correct. It now becomes a base because you accepted proton and became that. Then we now go to the last definition of acid and base based on Lewis' definition. Lewis' definition of acid and base. In this regard, we are talking about electron pair. According to Lewis, an acid is an electron pair acceptor, while a base is an electron pair donor. Electron pair acceptor, electron pair donor. One gives the electron pair, the other one accepts it. Example of his acid is boron trifluoride. One example of his base is ammonia. You see it. An acid is an electron pair acceptor. This one accepts, and this one donates. You see it. So when both of them combine, they form a coordinate covalent bond. You have NH3 plus BF3 to give you NH3 BF3. The name of this compound is ammonium trifluoroborate. Trifluoroborate. So the type of bond holding them is a form of coordinate covalent bond. This is all we can take for today. But remember, there are going to be subsequent so many other videos that will cover a lot of areas in your skin. So don't just stay at home without going through your work. By God's grace, be expecting more videos. And please, as you get all these videos, kindly subscribe and share with your friends. God bless you.